I hope all of you are doing good. Let's start today's chapter, Geometrical Shapes. Triangles. Geometry is commonly found in architecture. Many bridges, buildings, space stations, tower, etc. have triangles as part of their constructions as they hold their shape very well fixed. You have already studied in class for about closed figures and polygons. A polygon is a simple closed figure made up of line segments. Some examples of polygons are these. You can see a polygon with 3 sides in figure given above. That is a triangle. This one, okay? Triangles around us. What is a triangle? A triangle is a simple closed figure made up of 3 line segments. It can be formed by joining 3 non-collinear points. Non-collinear points means points which are not in same line, right? It has a 3 line segment as its sides, AB, BC and AC, right? 3 vertices, A, B, C and 3 angles, angle A, angle B and angle C. The word triangle is made up of 2 words, that is a tri and angle. Tri means 3, so a triangle means a figure having 3 angles. The symbol, this is the symbol used for a triangle. So we name the above triangle as triangle ABC, this triangle, okay? And other names for triangle ABC are, you can also write triangle BCA or a triangle CAB or triangle ACB. The order of vertices doesn't not matter while naming a triangle, okay? Let's do exercise 10.1. Which of the following figures are a triangle? Obviously, you can easily tell which of the following figures are triangle, okay? And you have to tick that figure, okay? Classification of triangles. Triangles are classified and named according to the measures of their angles and lengths of their side by size of its angles. For every triangle, there are at least 2 acute angles. Therefore, the third angle of the triangle is used in classifying a triangle according to its angle. See, type of angle. All angles are acute. So, its name is acute angled triangle. All angles are acute means all angles are less than 90 degree or acute. This is acute triangle. If one angle is right, that is only one angle is equal to 90 degree, then its name is a right angled triangle or simply right triangle, okay? This is right angle. If one angle is an obtuse, that is if one angle is greater than 90, then it is known as obtuse angle triangle or obtuse angle. This is obtuse angle, okay? Okay, we have classified triangles here by size of its angle. Now, by lengths of its size. Just as triangles can be classified by the types of angles that they contain, they can also be classified according to the nature of sides that they have. Okay, length of sides. If all sides are equal, then this triangle is equilateral triangle, right? If 2 sides are equal, then this triangle is isosceles triangle, okay? And if all sides of different lengths, means no sides are equal, then it is scalene triangle, like this, right? Note, similar markings on the sides of a triangle show equal sides. See, these are the similar marking, that means all 3 sides are equal. Similar marking on the angles of a triangle shows equal length. If there are similar marking on angles, that means angles are equal. All equilateral triangles are isosceles triangles, but isosceles triangles are not equilateral triangles. Remember that, okay? Let's do exercise 10.2. Measure the side of the triangles and classify as equilateral, scalene or isosceles. So, you need a ruler or scale for this. You need to measure the length, all 3 sides of the triangle, and then you will classify or you will tell whether the triangle is equilateral, scalene or isosceles, right? Reflection and rotation. There are broadly 3 different ways of moving a picture from one place to the other in a plane without changing the shape or size of the figure, okay? Number 1, slide or translate figure. Number 2, reflect a figure across a line. This one, and rotate a figure around a point, right? Reflection. Reflection, as you normally understand, is seeing the image of something in a mirror. If you stand in front of a mirror, the mirror image is the reverse image of yours. Means right becomes left and left becomes right in a mirror image. You already know that. That is also known as lateral inversion. Similarly, reflection in geometry is a flipping a figure across the line such that it appears to be the mirror image of a reflection of the original object. Each point in the reflected figure, that is a mirror image, is at the same distance from the line as the corresponding point in the original object. The line is called the mirror line or line of symmetry. You have already learned about the line of symmetry, right? Look at the following reflection. See this reflection. A, B, C. A dash, B dash, C dash is the reflection of what? Is reflection of A, B, C in the given line. As can be seen, the distance of points A dash, B dash and C dash from the mirror lines are the same as the distance of point A, B, C respectively from mirror line. Some examples of reflection are, see, these are the reflections examples, okay. Now rotation. Rotation means a turning. In geometry, rotating a figure means turning a figure about a given point known as the center of rotation. This point can be on the figure or out of the figure. Some examples of rotation for real life situations are these, like rotation of the hands of a clock at point where they meet, steering wheel of a car about the center, knob of a door, okay. It also rotates, right? And windmill, it also rotates. You can also rotate 2D shapes or plane shapes about a point. These objects are needed to describe a rotation. The direction of rotation, clockwise or anti-clockwise, and the angle of rotation and the center of rotation. The example given here shows the rotation of a square about a given point out of the square. The square has been further divided into colored square to make its movements clear. Okay, see, this is the center of rotation. Now, shape A is rotated through an angle of 90 degree about the point P, okay, in the clockwise direction to get shape B. Clockwise, this direction is clockwise, okay. Shape B is further rotated through an angle of 90 degree about the same point P in the clockwise direction to get shape C. This is the same as if we would rotate shape A through an angle of 180 degree about point P in clockwise direction to get shape C. Okay, right. Now, shape C is again rotated by an angle of 90 degree about point P to get shape D. What happens when shape D is further rotated through an angle of 90 degree about point P in clockwise direction? We get back to shape A. Some more examples of rotation of geometrical figures are, see, given triangle is rotated about point A through an angle of 90 degree in the anti-clockwise direction. Means now here, given figures are rotated about point B, see these figures, through an angle 180 degree in the clockwise direction. See what happens to letter Z. This is letter Z. When it turns through an angle of 90 degree about P in a clockwise direction, it becomes a letter N, okay. Can you observe that a reflection followed by reflection is same as rotation by 180 degree? What do you say? Let's do exercise 10.3. Say whether the shape has been rotated or reflected. Okay, so A part, this is the reflection, so this has been reflected, okay, right. Symmetry in solids. Symmetry is the exact likeness in a shape about a given line, point or plane. You have already studied in class 4 that plane shapes of figures which can be folded over in such a way that the two parts match exactly are called symmetrical figures, and the fold line is called the line of symmetry. Okay, see, this is the line of symmetry. This in this rectangle, these are the line of symmetry. This is the line of symmetry in this case, and this is the line of symmetry. You are familiar with this term, symmetry, right? A symmetrical figure can have one line of symmetry or more than one line of symmetry. Like in this case, we have two lines of symmetry. Solids also show symmetry. Some solids can be cut into two halves so that both the halves are identical. Identical means same. The planes or that surface along which the solid is cut to give identical halves is called the plane of symmetry. If we put a mirror symbolizing a plane in front of each half, then each half is a reflection or mirror image of the other. Just as a flat, 2D shapes may have more than one line of symmetry. Similarly, solids can also have more than one plane of symmetry. See, this is vertical cut, horizontal cut, vertical cut. Okay, each cut is dividing the given solid into two identical halves. Here are some more examples. See, a cone and a sphere have infinite number of planes of symmetry. Okay. A cube has many planes of symmetry. Here are some. Try to find out some with the help of your teacher by cutting a cubical box. Let's do exercise 10.4. Write yes or no in the given box to indicate whether the highlighted plane is cutting the solid into two identical halves or not. Okay, are these the two identical halves? No. And what about in this case? Yes. Okay. Now, nets. If you could cut a 3D, that is a solid shape, along some of its edges and open it out flat, you would get the net of the solid shape. A net can be folded to make up the 3D shape. If you open up a cube by cutting along its edges and then lay it flat, you would get the net of the cube, which looks like the following. See, this is a net of a cube. If you fold it up, it forms a cube. This we see that a net is a two-dimensional figure, which when folded, then it forms a three-dimensional figure. Right? Remember, net is a two-dimensional figure, but when folded, it forms a three-dimensional figure. Right? There may be several possible nets for a 3D shape. Here are the nets of some common 3D shapes, you know. See, cube. These are the nets of cube and cuboid, cylinder, cone, right? Square, pyramid, triangular, prism, right? Now exercise 10.5. Match the nets of their respective solids. Okay, can you match this net? Okay, this net is of which solid? See, this is cylinder, right? And I'm sure you can match all these nets to their respective solids, right students? And now you will do practice of the remaining questions, right?